Let's say there are n signals to be transmitted. Let all the n signals have the bandwidth of FM1, FM2 up to, let's say, FMN. So the question is, what will be the total bandwidth required in TDM system, or I will call it TDM PAM system. So in TDM PAM system, the total channel bandwidth required, or the bandwidth of the composite signal that gets generated, because bandwidth of composite signal is nothing but the minimum channel bandwidth required. So channel bandwidth required will be equal to, this will be nothing but the sum of all the bandwidth, so FM1 plus FM2 up to FMN. If we have FM1 equal to FM2 equal to up to FMM, if all the bandwidths of the signals are of exactly same bandwidth equal to, let's say, FM, in that case the total channel bandwidth required, or the bandwidth of the composite signal, will be equal to n times FM. So you can see this is exactly the same bandwidth are required in FDM system also, and hence there is no advantage in terms of any bandwidth saving in case of TDM system compared to FDM system. Alright, but please remember that this bandwidth expressions are only valid when the sampling is done at Nyquist rate. The Nyquist rate is nothing but Fs equal to twice Fn. Generally we always sample the signal at a value Fs greater than twice Fm, and if that is the case, then we have to use another expression of the channel bandwidth required. The expression will be in the form of the sampling frequency that we are using. So in that case it will be nothing but Fs1 by 2 plus Fs2 by 2 up to Fsn by 2, where Fs1 will be sampling frequency used for the first signal, Fs2 will be sampling frequency used for the second signal, and so on. So I can keep this half outside, and it will be Fs1 plus Fs2 plus dot 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 Fsn. You can now see that if sampling is done at Nyquist rate, then I can put Fs equal to twice Fm. So if I put Fs1 equal to twice Fm1, then 2 will cancel out, I'll get Fm1. If Fs2 is twice Fm2, 2 will cancel out, I'll get Fm2. But if the sampling is done at a value greater than 2Fm, then I have to use this expression for the bandwidth. For example, if Fm1 is 5K and if the sampling is done at 10 kHz, then half into 10K will give me 5K anyways. But if the sampling is done at 12 kHz, let's say for example, then it will be 12K here, by 2 will give me 6K. So instead of 5K, I'll have to consider 6 kHz because I'm considering more number of samples compared to Nyquist rate. So you can see this excess of bandwidth, this bandwidth will be more compared to the sum of original signal bandwidths, because we will always, in practice, we always sample the signal at a value greater than 2Fm and not equal to 2Fm. So this extra bandwidth will be something similar to the guard bands that we require in FDM. So once again we prove that if even after you consider the guard bands in FDM system, then we do not require more bandwidth in FDM compared to TDM, because in TDM also when we sample the signal at a rate greater than Nyquist rate, we will be using that extra bandwidth than what is required ideally. So that's the TDM PAM system. We will now define a combination of TDM and PCM. PCM system, if you remember, is the system in which we sample as well as quantize the signal. In TDM system, we send the signal in sample form. In PCM system, we send the signal in the form of bits, ones and zeros. So how can we club TDM with PCM and define a new system?